Okie dokie. I realized I had not uploaded videos on this problem type, so let's get right into it. They say if a radioactive mass declines in potency from that value or that many clicks per hour in 1990 to that many clicks per hour in 2000, what will the level of radioactivity be in 2026? The first step is to figure out what t values we will use to represent each of these years. We are not going to use 1990, 2000, and 2026 as our t values. We're going to first go ahead and label the earliest year as time 0. So 1990, our earliest year, will be time 0. So every other year past that will be kind of in reference to 1990. So t is going to represent the number of years since 1990. So if we want to represent the year 2000, that's 10 years since 1990. So t will equal 10. Time 10 will represent the year 2000. So then later on, for 2026, we will use the time value of 36 because 2026 is 36 years after 1990. So now that we have that, we are going to be using the sort of structure y is equal to CE to the k times t. So this is our exponential growth or exponential decay function because we have a decline in a real life scenario here. It's usually an exponential decay. So first thing is this. We're going to set up basically two ordered pairs of the year 1990 represented with the t value of 0 and the number of clicks per hour that it had in 1990. So there was 47,619 clicks. And then we'll set up another ordered pair with the given information that in the year 2000, or at time 10, we had 44,776 clicks. So with these two ordered pairs, what is this going to give us? The number of clicks that corresponds to a time value of 0 is actually going to be our C value. It's going to be what we'll use as the initial amount of number of clicks per hour, right? So that's our C value. Whatever Y value corresponds to the X value of 0, in other words, is our C value. With that in mind, we're going to use the C value, the T value, and the number of clicks, or the Y value, and we're going to set up an equation, and this will help us to solve for K. So we're going to plug in 44,776. So we're plugging values into this equation, right? Plugging in 44,776 in place of Y equals C, which is 47,619, e to the K, which we do not know, but we do know that T is 10 because time 10 corresponds to a Y value of 44,776. So it's like plugging in an ordered pair to this function and just making sure we also have the C value plugged in. We want to solve for K. That's our next goal. We're solving for K. So we do so by dividing by the 47,619, and then we have whatever that is, 44,776 divided by 47,619.
It's approximately 0.9402.
All right, so we have this equals e to the k times 10. We want to eliminate e, so we take the natural log of both sides. Those cancel each other out. We're left with k times 10. And so I'm just going to leave it as natural log for now. And then to get k by itself, we divide by 10. So we get whatever that is. How do I want to do this? Let's use Desmos, Excel. Let's use Excel. Let's get some practice there. All right, so real quick, just doing equals ln in parentheses 0.9402, and then we divide by 10. So right away, this is our k value, so we have that within Excel, which we can then use in just a moment. But I'll go ahead and write it here as well. So k is equal to negative 0.00617. So about negative 0.0062. So now, what are we trying to do? We're trying to find the level of radioactivity in 2026. So now with this K value, and with our C value, and with this T value that represents the year 2026, we should be able to solve for the Y value, which will represent the clicks per hour in the year 2026. So I'm just going to do it to the side here. Should be able to see everything, hopefully. So we're solving for Y. The C value is the same, right? So 47,619. E to the K, which we just found, negative 0.0062 times T, for which we're plugging in 36 because we're finding the number of clicks in the year 2026. 36 represents that year, etc. This is something we can calculate within Excel. All right, let's give it a go. Let's do it here. 47,619 times E, which is represented with EXP, and whatever goes in parentheses represents whatever was in the exponent place of the E term. So we're going to have actually what I'll do is click on this to represent the K, and then I'll multiply that by 36. And then close that off. So 47 times the E to the K times T. We hit enter, we get 38,139. 38,139. And we look at our answer choices. And how did we do? 38,139. 38,139. Not having any luck. So I think my biggest recommendation would be we cannot round. So when I did, I think even back here, let me see if I get a different value for that. I could have easily typed something in wrong. Having kind of a long night here. This divided by 47,619. Okay, so it does go a little bit crazier. Okay, so look at this. So that was the decimal that gets plugged into the ln. So let me try retyping this. And in place of this, I'm going to actually click on this. So watch how that changed. Okay, you see that? So I don't know if anyone knows what happened here, but what I did was instead, so like right here in the work, I made sure I used a way bigger decimal. So use more decimal places, then take the natural log, then divide by 10, whatever. So I might recommend do it all in Excel. So we divided these numbers, took the natural log of that number, divided it by 10. We got this, and then again, this value played into this calculation here for the final answer. And now look at what we got. We got 38,153 clicks per hour. That's option B. And option B, once I erase this here, give me a sec. Option B is our answer. So, very long, very slow version of this problem. I have one more, and I'm going to do it to show how fast this problem can be. This is the very turtle-y version, very slow version, right? Example 2. Here we go. Y'all ready for this? We have t equals 0. First year is 1977. After that, we have 1998, which is 21 years later. So 1998 is 21 years later. Then times something for 2017. What's the difference? That's 40, right? 77 to 2017. So time 40. Okay, so for these first two values, let's come up with our ordered pairs. We have 0, 37,998 for the number of clicks. For the next ordered pair, we have 21 in the year 1998 with 36,400 clicks. We have our C value now of 37,998. That just comes from this first ordered pair. We are setting up the equation y equals CE to the KT using this ordered pair and using the C value. So we have 36,400 equals 37,998 e to the k times 21. We are solving for k. So we're going to divide by 37,998, take the natural log of both sides, to get rid of the e, and then we're going to divide by 21. So see how all that worked? It's pretty fast, right? Let's give this a go. Using Excel, we'll kind of scroll down, start fresh. We're just calculating this right here. So just natural log 36400 divided by 37998, just like that. Then divide, close the parentheses, then divide the whole thing by 21. We get this. This is our k value, just like that. Now we will go ahead and write out the equation we'll set up, but then we'll just plug it right into Excel. Okay, time 40, c value, and then I guess k value. Just jot it down here, negative 0.002 roughly. Okay, so the equation we set up is y equals c, which is the 37998, e to the k, which I'll use the Excel value for, times 40, because 40 is the time value that we're plugging in. So we're finding the number of clicks in the year 2017. Right? Let's give it a go. In Excel, easy peasy, do 37998 times exp to represent the e to some power. So in the parentheses we put that power, so we put the k value, which was calculated exactly in Excel, times 40. Hit enter, we get 35,012. So 35,012, that's option C. We have our answer just like that. See, so that was much faster than the first one, but hopefully the full breakdown of the first one was helpful in going through my error that I made of not using enough decimal places. And I got, like 10 off, 15 off of the answer almost, by using not enough decimal places. So make sure to use enough decimal places. Use Excel. It's a very useful tool. And all right. Thanks for watching. If you have questions, let me know.